I'm going to start with question number 4. In this question, the question wants you to find the differentiated form of cosine cubed 2x. Okay, so remember that when you differentiate cosine cubed 2x, you will need to deal with the 3 first. So I'll bring the 3 down to get 3 cosine, and then the power minus 1 to get 2. And this is what we have. And then after that, we will need to differentiate the inside without the cube. So differentiation of cosine 2x will get you negative sine 2x. And after which, it will be the last part, the last layer of the thermal wear, which is the innermost layer, that's 2x. And that gives you 2. So if you expand them, you will get negative 6 cosine square 2x sine 2x. Now, I'm not going to leave my answer like this reason because in the second part, the question needs you to get sine cubed 2x. So I will need to do some manipulation in order to get the answer to involve sine cubed 2x. So what I'm going to use is this identity, sine square 2x plus cosine square 2x is equals to 1. So by making my cosine square 2x the subject, I get 1 minus sine square 2x. So by substituting that in, I will get this. And after expansion, this is what I'm going to get, minus 6 sine 2x plus 6 sine cubed 2x. Okay? So this is what we want for the first part because as you can see, it involves the sine cubed 2x that we will need in the second part. Okay, now we'll be looking at the second part, the evaluate part. I've written my answer for the first part on top due to space constraints. So what we're going to do is, remember, you have to do the reverse. So we're going to write integration of negative 6 sine 2x plus 6 sine cubed 2x dx. This thing will give us cosine cubed 2x. Okay, so now with the limits that we are given, we can insert that in, pi over 4 and 0, pi over 4 and 0. Okay, so what we want is the sine cubed 2x only, so I'm going to split this 2 separately so that I can make my sine cubed 2x the subject later on. So I have integration of negative 6 sine 2x dx plus integration of 6 sine cubed 2x dx. Okay, with the limits. Okay, so to make this this thing here the subject, I will be shifting this entire thing over, and that gives me this plus integration of okay, so this thing here, just your normal substitution, and this one, what you just need to do is to do your normal integration. This is just a very simple integration. Unlike this one over here, you wouldn't know how to integrate if we are not given this clue about working backwards. Okay, so you should have this thing here to be cosine. Integration of your sine will give you negative, so negative 6 cosine 2x over your coefficient of 2. Okay, so you could actually choose to simplify this first to become 3 and 1 before you start your substitution. Okay, so after you have substituted and gotten your answer for this part and this part, you should get your answer for your 6 sine cubed 2x to be equivalent to 2. Okay, so after you have gotten the answer for the 2 highlighted ones to equate to 2, then now we're going to deal with what the question wants. The question wants you to find 2 sine cube 2x. So how do we make 6 become 2? That's very simple. Just multiply by 1/3, or you could divide by 3 throughout. It's the same. So by doing this, this will become 2 sine cube 2x dx, and this thing here will become 2/3. So our final answer to evaluate the value of 2 sine cube 2x dx is 2/3. So 2/3 is the answer for the second part. For question number 5, part 1, we are doing a proving question. I'm going to start with the left-hand side because it's more complicated. So it's easier to start with the more complicated side to simplify it. So we have 1 minus tangent square A over 1 plus tangent square A. And because the right-hand side involves sine and cosine, I'm going to change my tangent square A here to involve sine and cosine. That is by using this formula, tangent A is equals to sine A over cosine A. So this will become 1 minus sine square A over cosine square A. Now, because this is already a fraction, and I mentioned before, if you have a fraction over a fraction, instead of writing them vertically, we are going to write them horizontally, which is side by side. So divides by your 1 plus tangent square A. And we know that according to our identity, 1 plus tangent square A is equals to secant square A. So this thing here, I'm going to write it as secant square A. So for this first part, I'm going to combine them under one single denominator. That gives me cosine square A minus sine square A over cosine square A. So multiplies by 1 over secant square A. And we know that one over secant square A is in fact cosine square A. So by writing it like that, we can simplify this by cancelling this, and that leaves us with your cosine square A minus sine square A. And this is what our right-hand side is equivalent to, and that's how we can prove that. If you have any other ways of proving and you would like me to check, just feel free to send it to me. I'll look through it for you. Alright, in the second part, we'll need to evaluate the exact value of this. So by using hands, we can use part 1's answer. Let me copy the question first. Okay, with the word hands, we'll need to use your part 1's answer, and we know that this part of 1 minus tangent square A over 1 plus tangent square A is equivalent to your cosine square A minus sine square A dA. Okay, once you get this, do not start to do your integration yet. Okay, there's one more thing that you can do to make it even simpler before you do your integration. Now, if you recall your double angle formula, cosine 2A is equivalent to cosine square A minus sine square A. Now, that's why I say, even though all those formulas are given in your formula list, you will still need to get familiarized with them so that when you see equations or expressions like this, those identities will come to your mind, like what to use. Okay, so because you know that cosine 2A equals to cosine square A minus sine square A, I could substitute that as cosine 2A over here. So once you have substituted this as cosine 2A, you can then start to do your integration to get your sine 2A over your coefficient of 2, and then by substituting in, you will be able to get the exact value, and you're expecting to get your overall answer to be 0. So 0 is the answer for 5 part 2. Okay, so do take note of this shortcut to simplify it before you start doing your integration. For question number 6, they want you to differentiate this with respect to x. So as you can see, this is an algebra multiplied by another algebraic term, so we will need to use product rule when we are differentiating this. So you can write your d dx, x squared e to the power of 3x minus 1. So remember, we have to copy one, differentiate one, plus the reverse of the other. So I'm going to copy my x squared and differentiate my e to the power of 3x. Remember, when we are differentiating exponential terms, it's exactly the same, but just remember to multiply it by the differentiated form of this, which is the coefficient of 3. And then you copy the other one, e to the power of 3x minus 1, differentiating your x squared, which gives you 2x. So if you expand them, you will get 3x squared e to the power of 3x minus 1 plus 2x e to the power of 3x minus 1. You notice that my exponential term is always written at the end of every term, so it's neater and easier for you to do any factorization later on. Okay, so what I'm going to do again is that I'm going to check this with reference to what the question wants in the second part. And I realized that it looks like it's actually factorized in the second part. So I'm going to do the same. So I'm going to take out my common factor, which in this case is e to the power of 3x. Of course, we know that x is also a common factor, but it's not actually required for the second part. So I'm just going to take out my e to the power of 3x. So then I will have my 3x squared plus 2x. Okay, so this is my answer for the first part. All right, so now we're going to deal with the second part, which is evaluating that. So as you know, when we are given the first part of differentiating, we will need to do the reverse. So we will write integration of e to the power of 3x minus 1 multiplies by this. Remember to write the dx, and it's equivalent to the term over here, x squared e to the power of 3x minus 1. And with the limits to 1, we can insert that in. So right now what we're going to do is we're going to compare this. Sorry, highlighter is not activated. We're going to compare this with respect to this one, and you can see that it's exactly the same as what the question wants, so no amendments is necessary. You can just basically just do your substitution over here. So after doing your substitution, you will get your answer to be 586 when rounded off to 3SF. So the answer for the second part is 586. Alright, for question number 7, part 1, we need to differentiate this with respect to x. So as you can see, this is a product of two algebraic terms. So we'll need to use our product rule to differentiate this. It's similar to question number 6. So I'm going to copy my x and then differentiate my e to the power of 3x. And that gives me this 3 e to the power of 3x. And then after that, I copy my e to the power of 3x and differentiate my x, which gives me 1. So after expansion, I will get this plus this. Now, so before I start to do any manipulation or factorization, I will need to check what part 2 is asking. Part 2 is asking me to find x e to the power of 3x, which is over here. So I'm not going to factorize anything or manipulate any formula for my part 1, because later on I will need to make this part here the subject so that I can solve for my part 2. So my answer for 7 part 1, I will leave it as it is. Just this one, 3x e to the power of 3x plus e to the power of 3x. For second part, we will need to write the reverse. Start by writing the reverse. So we write integration of 3x e to the power of 3x plus e to the power of 3x dx is equivalent to this one. Remember, this must be written in square brackets to tell ourselves that it is integrated already. Then you have your limits 1, 0. And as you can see from the second part, I want to find this. So I'll need to split these two separately so I can make this part here the subject later on. So I have this. Okay, so what I'm going to do is I'm going to shift this over so that this can become the subject. Okay, this part is just the normal substitution, and then this one, same thing. It's the normal integration as well. So you have your e to the power of 3x divides by 3. Okay, and then after you simplify, after you do the substitution, you should get this answer here to be 13.7237 in like at least 5SF. Okay, so same thing like what we did just now for question number 4. We are going to go back to what the question wants. The question wants just x e to the power of 3x. So because we know that now, what we have is that 3x e to the power of 3x dx is equivalent to 13.7237. To get x e to the power of 3x dx, we'll just need to divide by 3. Okay, so you divide by 3 to both sides, and then you will get your final answer to be 4.57 when rounded off to 3SF. Okay, so the answer for integration of x e to the power of 3x dx is 4.57. So you can see that questions number 7, part 2 and 4 will actually involve more complicated skills of making a part of your differentiated form the subject. So it is really important that I want you to keep it consistent, that every time you do working backwards, always start by writing out this, which is the reverse, and then making that the subject and eventually getting to what the question wants. This will simplify your steps more easily, and then it's going to be more consistent. So you don't have to think about different ways to do it for different kind of questions. So keep it the same for every question so that you have the same steps and you have the same concept to fall back on when you're solving for such questions. Okay, if you have any further questions after watching all these videos, please feel free to check in with me, and then so any further clarifications, I will be able to advise you on that. Okay.